Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 2 class. It is solving by factoring day 1. Factoring we talked about in our last lesson a little bit. It's where we had our GCF, we'd factor it out, and we could solve our equation. So the objective of this is to factor and solve quadratic equations. Here are your 4 steps for factoring polynomials of the form x squared plus bx plus c, which we know as standard form. We know that as standard form. Okay? The first step is to find a GCF. Remember that is the greatest common factor. That is the numbers that are 3 parts of our trinomial will share together. All right? The second step is when I have an x squared. When it is factored, I'm going to have 2 sets of parentheses. There are 2 blanks in each set of parentheses. There will be a sign in between them. The first blank is always going to be filled with an x. That is your step 2, is to create 2 sets of parentheses. Fill the first blank with an x. Okay. Step 3, this is probably one of the more difficult steps because there are a few different things you can do here. So if our c value is positive. So if our c value is positive, what's going to happen is inside our parentheses, remember we already have an x at the beginning, right? What's going to happen inside our parentheses is we'll either have a positive and a positive, or we will have a negative and a negative. We will talk about what we fill in that back part of that in a second, okay? If our c value is negative, so again, we're still looking at the same c value. If it is negative, I'm going to fill the sign in between my x and my blank with a positive in the first one and a negative in the second one, or a negative in the first set of parentheses and a positive in the second set of parentheses. All right? You want to make sure that throughout this lesson you keep referring back to step 3. It will sooner or later click and you will understand it, okay? Step 4, we need to find our factors of our c value, okay? And when we find the factors of our c value, remember in the first blank it's going to be an x, then I'm going to have a sign, either a positive or a negative. Then I'm going to put my factor of my c in this location. I'm also going to put one of my factors of my c in that location. Don't freak out about that positive and negative that I put in there. That just means it could either be a positive sign or a negative sign in those locations. That's all that means, okay? So when you're done, you're going to have an x. It will be plus or minus a number times x plus or minus a number. That is basically everything we just talked about right there. Okay, so for the first example, we need to factor each polynomial using GCF and binomial factorization. Binomial factorization is using 2 sets of parentheses. That is binomial factorization. All right. So the first step is to see if I have a GCF. If you ever have a problem that does not have a number out front of my x squared, but has numbers all the way through the rest of it, there will be no GCF. Okay, there will not be a GCF in that problem. They cannot share any numbers. There's no x at the back end of this 15, so they can't even share an x at this point. So there is no GCF for problem number 1. What I'm going to do is then jump to step 2. Step 2 means I'm going to make 2 sets of parentheses with an x in my first blank. Now I'm going to look at step 3. It says if my c value, which is right here, is positive, then I'm either going to have a positive positive or a negative negative. How I know which one of those I'm going to put in there comes from the sign of my b value. So since my c value is positive and my b value is negative, I'm going to put negative negative in that location. All right? Now we need to worry about step 4. That is the factors of 15. Well, I can have 15 times 1, and I can have 3 times 5. What I'm going to do is figure out which set will add to my negative 8. Can any combination of 15 and 1 ever add to negative 8? No, it can't. I can't have negative 15 plus 1 and have it be negative 8. I can't have negative 15 minus 1 have it be negative 8. I can't have negative 15 or positive 15 plus 1 be negative 8, or positive 15 minus 1 be negative 8, right? What about 3 and 5, though? Is there a way that I could make 3 and 5 add to negative 8? Well, what about 3 minus 5? That would get me negative 2, so that's not going to work. How about negative 3 plus 5? That would get me positive 2. That won't work. How about 3? We already did 3 minus 5, so the only thing left is to make them both negative, right? Well, negative 3 minus 5 would be negative 8, so that will in fact work. I'll go ahead and just plug my 3 and my 5 in there, and we are good. All right? That is binomial factorization. That is all it is right there. Okay? So going on to problem number 2. There's no number in front of my x squared. There's no x behind my 8. So that means I will not have a GCF. I'm going to jump straight to step 2. Since I have an x squared, I can make 2 sets of parentheses with an x in the first blank. Since my c value is negative, right, we're going to look at the second line here. I'm either going to have a positive or a negative and a positive. In this case, it does not matter which one goes in which parenthesis. We will figure out how to fix that with our numbers at the end. So looking at 8, how do I multiply to 8? Well, there's 1 times 8, and there's 2 times 4. All right? I need to have those numbers get me to negative 2. Is there any combination of 1 and 8 that can add to negative 2? I don't believe so. So we're going to get rid of that. Okay? How about 2 and 4? Is there any combination of 2 and 4 that can get me to negative 2? Let's try negative 2 plus 4. I know that one of them has to be positive and one of them has to be negative, right? So that is one way I can work through this a little quicker. Negative 2 plus 4 get me positive 2. That's not what we're looking for because we're looking for a negative 2, right? How about negative 4 plus 2? Well, negative 4 plus 2 would get me negative 2. Perfect. I know that my 4 then needs to be negative and my 2 needs to be positive, and we are done. All right. On to number 3. Again, the first thing I look for is there a number in front of my x squared? There is not. Is there an x behind my c value? There is not, so there will not be a GCF in this case. What I'll do then is move on to step 2, which is to make 2 sets of parentheses, have my x in the first blank. My c value is positive. Since my c value is positive, I know that both of my signs in my parentheses will be the same. Since they're going to be the same, I need to find some other location that will tell me what my sign should be. That is right there. So both of my signs would be positive. Same. Okay? Now, I have to figure out what multiplies to 5 and will add to 6. Well, the only things that multiply to 5 are 5 and 1. Does 5 plus 1 get me 6? Yes, it does. So I can just put 5 and 1 in my blanks, and I am good. All right. Number 4, this is really our first tricky one. Most people look at 9, and the only thing they can think of that will multiply to 9 is 3 and 3. So they'll look at that problem once they get rolling with this and really understand what they're doing, and they're going to say, oh, it's not possible to have 3 and 3 get to 8. I'm going to show you how it is possible. The first step, check the front. Is there a number? There is not. Check the back. Is there an x with that 9? There is not. So we're going to go ahead and make our 2 sets of parentheses. When my c value is negative, I know that my signs will be opposite of one another. We talked about that in problem number 2. Okay? Now, I have to figure out what multiplies to 9. There is 1 times 9 and 3 times 3. I need to find something that will add to negative 8. Some combination of 1 and 9 or some combination of 3 and 3 that will add to 8. Well, if I have a positive 3 and a negative 3, will that add to 8? No, it won't. So 3 and 3 will not work. How about 1 and 9? Is there some combination of 1 and 9 that can get me to negative 8? If I do negative 1 plus 9, I would get to positive 8. So that won't work. How about if I do positive 1 and negative 9? That will get me to negative 8. So since I had a negative 9, I'll put 9 where the negative sign is. I had a positive 1, I'll put 1 where the positive sign is, or the addition sign. And we are done. Now, on to number 5. This one, I need to think about a GCF because I have a number in front of my x squared and I have a number at the end. So it's possible that I could have a GCF here. Let's see what my GCF would be. Well, this would be 3 times 1 times x, right? 48, I wonder if 48 is divisible by 3. Let's see. If I take 48 and divide by 3, I'll end up with 16. That works. So I know that they share a 3. Do they share anything else? No, they don't. So what I can do is make this 3 times what's left from my first tree, x squared. What's left from my second tree, 16. Now, here is one other thing you need to be careful of. Since my 3 in my problem right here is negative and my 48 is negative, my GCF is actually going to be negative 3. If they're both negative like that, what I want to end up doing is making sure that my x squared is positive. All right, so what I really did is I pulled out a negative 3. So negative 3 divided by negative 3 would get me 1, which is 1x squared. Negative 48 divided by negative 3 would get me a positive 16. All right. On to number 6. I have a number in front of my x squared and I have a number back here. Now, in order for us to have a GCF, all 3 of those must share a certain number. For the first one, it's 3 times x. Not all of them have x's, so x will not be part of my GCF. But it looks like 3 could be. So what I'm going to do is I just want to find out if 18 is divisible by 3. If I take 18 and divide by 3, I would get 6, so 3 times 6 would work. There is an x left there. 24, I wonder if that's divisible by 3. If I take 24 and divide by 3, I'll end up with 3 times 8. Is there something that all 3 share? Yes, there is. It is a 3. Since my x squared would be positive, by pulling out a positive 3, I'm just going to use positive 3 as my GCF. So that would get me 3 times what's left from my first tree, x squared. What's left from my second tree, 6x. What's left from my third tree, it would be 8. Okay? 3 divided by 3 is positive 1. Negative 18 divided by 3 is negative 6. Positive 24 divided by 3 would be positive 8. The next step here, though, is to see if I can factor x squared minus 6x plus 8. X squared minus 6x plus 8. All right? So what I'm going to do, is there anything else I can, any other GCF I can take out of the x squared minus 6x plus 8? There is not. So step 2 of factoring is to make 2 sets of parentheses with an x in the beginning. Since my c value is positive and my b value is negative, same, right? If there's a positive in the back end, that means that I will just follow the sign from the front. Now I need to find what 8 or multiplies into 8. I have 1 times 8 and 2 times 4. Is there any combination of 1 and 8 that can get me to negative 6? There is not, so I will not use 1 and 8. Is there a combination of 2 and 4 that I could use, though, that would get me to negative 6? I know that both of my signs will have to be negative, looking down here at my parentheses. So if I do negative 2 minus 4, will that get me negative 6? Yes, it does. So 2 and 4 would go in my blanks, and I have used a GCF, and I have factored to factor that completely. On to number 7. Is there a number in front of my x squared? No, there's not. Is there an x behind my 32? No, there's not. So do I have a GCF here? No, I don't. So I'm going to jump straight to step 2, which is to make 2 sets of parentheses. Put an x in the beginning. My c value is negative. So that means that my 2 signs will be opposite one another. All right. Well, 32 has a couple different ways that I could multiply to get to 32. I could have 1 times 32. I could have 2 times 16. And I could have 8 times 4. All right. So I need to find which one of those sets of numbers will allow me to get to a positive 14 using one of the numbers being positive and one of the numbers being negative. Let's look at 1 and 32. Is there any combination of 1 and 32 that will get me to 14? Well, negative 1 plus 32 would be 31, so that's not going to work. Positive 1 minus 32 would be negative 31, so that's not going to work. So 1 and 32 will not work. All right. How about 2 and 16? Is there any combination of 2 and 16 that will get me to positive 14? If I have a negative 2 and a positive 16, what will that add to? It will add to a positive 14. Since I know that my 2 has to be negative, I'll put that with the subtraction sign. I know that my 16 has to be positive. I will put that with my addition sign. And I am done. I have factored that completely. On to number 8. There is no number in front of that x to the 4th, but there is an x squared on the back end. So I need to be careful here. This means I will have a GCF. Well, x to the 4th I'll break into x times x times x times x. 17 could break into 17 times x times x times x. And 60, there's a lot of ways I could write the number 60, but looking at the first 2 groups, the first 2 trees I have, the only thing that they share is going to be x's, right? So I don't really need to break up the number 16 or 60 right now. So it'll be 60 times x times x. All right. What do all 3 share? They do share one x. So I'll bring an x up here. I'm done with that x. Okay. They also share a second x. So that would mean x times x. Now I'm done with that x. Do they share anything else? No, they don't. So my GCF would be x squared. I'm going to go ahead and bring my x squared out in front of the parentheses. What's left for my first tree? X squared. What's left for my second tree? 17x. What's left for my third tree? 60. My signs are both positive in my initial problem, so my signs will be positive again. Are we done yet? I am not 100% sure. I'm going to look to see if I can take a GCF out of what's inside the parentheses. In this case, I would not be able to. But now I want to look at what I can multiply to get to 60. I could have 1 times 60. I could have 2 times 30. I could have 3 times 20. And I could have 5 times 12. Looking at all those numbers, there are only 2 that could ever possibly get me to 17, right? 1 and 60 would never get me to 17. 2 and 30 could never get me to 17. 3 and 20 could, and 5 and 12 could. So, going back to our step 2, I have x squared. I want to make 2 sets of parentheses to factor what's inside the parentheses, right? I'm going to put an x in the beginning. Both of my signs are positive, so both of my signs will be positive. That means that the combination of the numbers from over here would both need to be positive. So if I have positive 3 plus 20, will that give me 17? No, that's going to give me 23. That's not going to work, so 3 and 20 won't work. How about 5 plus 12? Will that give me 17? Yes, it will. So 5 and 12 is what I would use. And I have now factored that completely. On to the back. This is factoring to solve quadratic equations. We're going to use what's called the zero product property to solve the following equation. If I have two sets of parentheses, x plus 3 times x minus 5 equals 0. What that means is I can then say x plus 3 equals 0 and x minus 5 equals 0. The reason I can do that is if either of those answers for x plus 3 or x minus 5 happen to equal 0, then the entire problem would equal 0, because anytime I multiply by 0, it does in fact equal 0. All right? So let's look at number 9. The first step is going to be to factor. So we want to factor it first. The first step to factoring is to see if we have a GCF. There's no number in front of my x squared, and there's no x behind my 10. So I will not have a GCF here. So I'm going to jump straight to my second step, which is making two sets of parentheses with an x in the beginning. All that is going to be equal to 0. That is very, very important that we keep the equal to 0 there. All right? Both my signs in the initial problem are positive, so both my signs inside my new sets of parentheses will also be positive. Now, I need to figure out what 10 multiplies into that can add to my 7. I'd have 1 times 10 and 2 times 5. Those are the only things that add or multiply to 10, right? Since both of my signs in my new parentheses are positive, that means whatever combination I use from these sets of numbers up here, both will have to be positive, right? So 1 plus 10 would get me 11. So 1 and 10 won't work. Will 2 plus 5 get me 7? Yes, it will. So my numbers are 2 and 5. All right? Now, going back up here, using the zero product property, since I have x plus 2 times x plus 5 is equal to 0, I can now say that x plus 2 is equal to 0 and x plus 5 is equal to 0. In order to solve this first problem, I can just subtract 2 from both sides. X would equal negative 2. For the second problem right here, I can subtract 5 from both sides. So x equals negative 5. Once you have split those into x plus 2 equals 0 and x plus 5 equals 0, it kind of really just turns into two separate problems that you need to solve on their own. So x would be equal negative 2 and negative 5. All right. On to problem number 10. I have x squared minus 3x minus 10. There's no number in front of my x squared. There's no x behind my 10. So I'm going to jump straight to step 2 in my factoring process. What's always in front is going to be x's. Since my c value is negative, I know that 1 will be positive and 1 will be negative. Again, what multiplies to 10? 1 times 10 and 2 times 5. Is there any combination of 1 and 10 that will ever get me to 3? No, there's not. I can't make it negative 10 plus 1 and have that be 3, or negative 1 plus 10 and have that be negative 3. How about 2 and 5, though? What is negative 2 plus 5? Well, that's positive 3. What is positive 2 minus 5? That's negative 3, so that's my winner right there, right? It's a positive 2, so I'm going to put the 2 with my positive sign. It's a negative 5, so I'm going to put that with my negative sign. Okay? Again, from here I can use the zero product property. So it would be x plus 2 is equal to 0, and x minus 5 is equal to 0. Now they're basically two separate problems. Subtract 2. X would equal negative 2. Here I'm going to add 5 to both sides, so x would equal positive 5. All right. On to number 11. I have 2x squared plus 20x minus 48. This looks to me like I could have a GCF. I'm going to go ahead and take a look. So 2 times x. Well, the only number I have here is 2, so I'm going to do 2 times 10 times x, because I know that the only thing they could possibly share is a 2, right? Same thing with the 48. I'm going to take 48 divided by 2. It would be 2 times 24. I'm just not going to break that 24 out any further because the only thing that they can all share is a 2. So a 2 is what they share, so my GCF in this case would be 2. Every time I have a GCF, I pull that out first, remake the parentheses. The first tree, I'd have x squared left. The second tree, I have 10x left. The third tree, I'll have a 24 left. All that, remember, is equal to 0. My first sign of my original problem was positive, so I want to keep that. My second sign of my original problem was negative, so I want to go ahead and keep that. From here, I want to look at only what's inside the parentheses. I need to factor what's inside the parentheses. Well, the first step to factoring is a GCF. Since there is no number in front of the x squared and no x behind the 24, there will not be a GCF. So I'm going to jump to my second step of factoring. Make sure you bring down that 2. That is still part of your problem. It'll be making 2 sets of parentheses with an x at the beginning. Always keep that equal to 0 at this point. All right. What multiplies to get us 24? Well, I have 1 times 24. I can have 2 times 12. I can have 4 times 6. And 3 times 8 actually as well. Will 1 and 24, any combination of 1 and 24 ever get me to 10? No, it won't. Now, so I can just get rid of that one right away. All right. Looking at my signs in this portion right here, I have a negative in the back and a positive in the front. Anytime my C value is negative, my signs will be opposite one another, right? So I know what I'm looking for now is that in my combinations of numbers here on the right, that 1 will have to be positive and 1 will have to be negative. Will 3 and 8 ever add to 10? That's not possible, right? So I can get rid of that one right away as well. 4 and 6 get me to 10, but both of them would have to be positive, right? So that would be gone because I know that one of my numbers has to be negative or positive and one of them has to be negative, correct? Well, let's look at 2 and 12. What combination of 2 and 12 will get me to positive 10? If I use a negative 2 plus 12, that would get me to positive 10. So since I know that, the 2 would go with the negative sign, the 12 would go with the positive sign. Okay? We have a couple more steps here, though. These problems get a little longer when I have an initial GCF. All right? Get rid of that little thing. I was just trying to get your attention there. All right. Now, using the zero product property, I can set all these individual pieces equal to 0. Now it's like I have 3 separate problems. The first one is this 2 equals 0. Well, does 2 equal 0? No, it doesn't. So that's just gone. I don't need to worry about it anymore. It's out of there. Okay? The second problem is x plus 12 equals 0. I can subtract 12. X would be equal to negative 12. That is one of my answers. X minus 2 equals 0 is my final problem. Add 2, add 2. X would be equal to 2. And that is my other answer. Number 12. What do you think? Do I have a GCF here? Well, I have a 2 in front of the x squared, and I have a 40. Everything there looks like it's divisible by 2. This would be 2 times x times x. Now that 2 is my only number, I'd take 24 divided by 2. That would get me 12, so it's 2 times 12 times x. And 40, 2 times 20. They all share a 2. So my GCF would equal 2. Remember to put that out front. What's left from my first tree? X squared. What's left from my second tree? 12x. What's left from my third tree? Just a 20. Remember to have that equal to 0. Both my signs in the initial problem are positive, so both my signs in my new parentheses will also be Positive. Okay? Now I need to factor what's inside the parentheses. Well, I have x squared plus 12x plus 20. Is there any way that I could have a GCF there? There is not. There is not any way I could have a GCF there, right? So I'm going to jump to my second step, which is to make two sets of parentheses. Remember, all these steps that I'm talking about were on the front side. It was steps 1 through 4 on steps for factoring polynomials. Okay? Since both my signs are positive, both my signs in my parentheses will also be positive. Now I have to figure out what I can multiply to get to 20. 1 times 20 would work. 2 times 10 would work. 4 times 5 would work. Right? From here, I need to see which one of these combinations of numbers could add up to 12. Could 1 and 20 ever add to 12? No. How about 4 and 5? Could that add to 12? No. 2 and 10 add to 12? Well, 2 plus 10 would get me 12, right? So since both of my signs are positive, it doesn't matter where I put those. I could make that x plus 10 times x plus 2, or I could make it x plus 2 times x plus 10 like I did. All right. Now I need to use the zero product property, so I'm going to set everything equal to 0 individually. I have 3 separate problems. We already talked about this 2 equals 0. It doesn't work. How about x plus 2 equals 0? What's my first step? Subtract by 2 on both sides, so x would equal negative 2. X plus 10 equals 0. I would subtract 10 on both sides, so x would equal negative 10. All right? Finally, number 13. Write the following in intercept form and find the x-intercepts. In order to write this in intercept form, I need to put it into 2 sets of parentheses. So it would be y equals a set of parentheses and a set of parentheses. Well, looking at that, that's pretty close to step 2 in my steps of factoring, right? Well, the next part of that would be to put 2 x's in the beginning, right? Now I'm going to look at my signs. Well, they're both positive here. So couldn't I just make both of these positive? I could. What's the last step to factoring? I need to find out what multiplies to 6. Well, I got 1 and 6 and 2 and 3. All right. Well, 1 and 6 could get me to 5. But looking at my problem over here, both of my signs need to be positive, right? So that means both 1 and 6 would have to be positive. Does 1 plus 6 get me to 5? Nope. So 1 and 6 would be gone. That doesn't work. How about 2 plus 3? That would get me to 5. So my numbers inside the parentheses would be 2 and 3. From here it says that I need to find my x-intercepts. Well, thinking back, our intercept form, all the intercept form work we did, I would take the 2 numbers, go opposite their signs, so it would be negative 2, 0, and negative 3, 0. So my x would equal negative 2, and my x would equal negative 3. And we are done. That is the end of our lesson. The most important part of this lesson is to memorize those steps of factoring. The sooner you can memorize those steps of factoring, 100%, the better off you're going to be. Factoring is going to be a big deal for the rest of the year. You really, really, really need to understand factoring, okay? So if you have any problems, make sure you come with questions tomorrow. All right. I will do my best to get around to everyone individually. If you have any questions, if you need to come in before school, please do so. Thank you very much for watching my video, and have a great day.